So if I set up the equation, I hat j hat, well, the I hat equation we've done already. Let's modify it some. So this will be C and that will be D. Those will be the speeds. So my I hat equation, 5 times 2, or let's stick in the order of mass times velocity, 2 times 5 plus 4 times -3 is equal to 2 times C cosine theta 2 plus 4, so I don't know how I want to define that. Considering the way I've defined theta 4 over there, minus 4 d cosine theta 4. I define theta 4 based upon the negative x-axis, so d times the cosine of -4 will be a component to the left, and that's why I have a minus sign here. My J equation, well, what is the left-hand side? What is my initial momentum before the collision in the J hat direction?
Q sine theta.
Before the collision?
Before.
Oh.
0.
0 equals 2 times, let's see, do we have to find it? So that's negative 2 c sine of theta 2 plus 4 d sine of theta 4. There's obviously, I've got 4 unknowns and 2 equations. I don't have enough, I need some other piece of information in order to actually solve this, but this is the basic setup here. And then if we bring in, well, then depends on what you want to bring in. If we're dealing with conservation, if it's a perfectly elastic two-dimensional collision, then we still have 43 joules would be, so if perfectly elastic 2D collision is equal to 1/2 times 2 times c squared plus 1/2 times 4 times d squared.
Where do you get 43 joules from?
Where do you have the?
43 joules.
We did it in the last problem, we figured out the kinetic energy beforehand. So I just pulled it from there.
So that comes from the kinetic energy formula.
Yes, absolutely.
Can it be anything other than a perfectly elastic?
Yeah, we can have it lose energy. If it's stuck together, it's not really a two-dimensional collision. Because you can't have two things with all the momentum in along this line right here stick together and suddenly go shooting off at some strange angle. At least not in classical physics. I'm just thinking of some of the twisted problems I've done. I haven't actually done this, but I could picture my mind at some point going, well, we've done a two-dimensional problem in class. Let's just have a wind blowing on it while it's moving. Yeah, having kids changed me. I just don't do that anymore. All right, master sets. So we got the two energy chapters, 8 and 9. So the homework quiz is then, you got the test that day, so let's make master set 8 and 9 due on the 5th. do that. When's Thanksgiving this year? 26th? Okay. So, 17th. So we have school that Tuesday, but not Thursday, all right, so when do you want the multiple choice test? I can suggest something if no one has any particular opinion on it.
Wait, is that 2 master sets in one day? Or did you split them up?
8 and 9, the energy ones, I was trying to remember if I had them as one master set or two. They're 8 and 9 are both energy. I might have combined them into one. Momentum, same way, I might have combined them into one, I just can't remember. All right, so let's do the multiple choice test on the 17th.
So how do you study for that one?
I get that question a lot, and I don't really have a good answer. To me, it's a mindset. Come in with a mindset. It's primarily reviewing the basic stuff from the first, well, basically the stuff through test 1B. But
What's it consent?
it's no calculator. Pardon?
Sure, that's the one.
Who? And actually, my first year of teaching community college, I found it online. I did, and I went back like 2 months afterwards, and I looked for it, and I couldn't find it. But any questions you remember, please feel free to talk to other people about it.
What's the
Before
average?
the test.
What's the average, like throughout all your classes? Do people normally do good on that one or worse?
At the lower levels, the average basically doubles from before the course to the end of the course. 251 usually starts out a little bit higher. So, but the average usually high teens, if my memory's right. Jesse.
Let's stop.